Electrical circuits that you find in most appliances, vehicles, or other applications are built by soldering the components to a printed circuit board. This provides a robust way of connecting components to each other without worrying that the connections will fail. However, when conducting experiments or testing the design of electrical circuits, it's necessary to be able to quickly and easily change the connections between components. To do this, we use a breadboard. To connect the components to one another, we don't have to solder them together. Instead, we simply place the terminal of a component into a hole on the breadboard. In the horizontal rows, when a wire is placed into a hole on the breadboard, it is electrically connected to any other wire that is placed in that row. We can see here that each row has 5 holes. So, if a wire is pushed into a hole in that row, it will be electrically connected with up to 4 other wires. By using the breadboard, it allows quick and easy circuit modifications without damaging any component. In the vertical columns, we can see that in each column there are many more than 5 holes that are connected to each other. These columns are typically used for connecting a battery or other voltage source, which must be connected to numerous components. These columns are often called rails, and can be labeled as the power rail or ground rail, depending on what is connected to them. Just like the horizontal rows, if a wire is connected to any hole in this column, all of the other holes in that column are electrically connected to that wire. To build a circuit on a breadboard, we must first start with a diagram of what we want to build. Let's first connect the voltage source, which in this case is a 1.5 volt battery. We are going to connect the positive side of our battery to one column and the negative side of our battery to the other column. Some breadboards have a plus and minus sign next to the columns, but it doesn't make a difference which one we use for each side of the battery. Looking at the diagram, we can see that the positive side of the battery is connected to one end of the 1.8 kiloohm resistor. To connect the resistor to the battery, first insert one end of the resistor into any row. Then, a wire is used to connect that row to the positive end of the battery. Now, that connection is complete. Next, we'll move to the node which connects all 3 resistors. Picking a row that is close to the 1.8 kiloohm resistor for that node will make things easier. Insert the free end of the 1.8K resistor into an empty row. Now, that row is the physical location of the top node. To electrically connect the 2 kiloohm and 3 kiloohm resistors to the 1.8 kiloohm resistor, they need to be inserted into the same row. On the bottom of the circuit, the 2K and 3K resistors are both connected to the negative side of the voltage source. To make this connection, there are 2 options. First, we can connect the 2 resistors together by placing them in the same row. Then, we can use a wire to connect that row to the negative rail. The second option is to skip the use of the wire and connect both resistors directly to the negative rail. In either case, we can see that the circuit has been completed.